all right triangles are very, very awesome, but there are a couple special right triangles. Those are our 30, 60, 90 right triangle and our 45, 45, 90 triangle. The reason they are special is there is a unique relationship that we can use to predict the lengths of its legs. If we were going to look at a 30, 60, 90 triangle, we knew the 30-degree angle. Across from the 30-degree angle, let's call that side K. That would mean that across from the 60-degree angle, that would be K, whatever that is, times the square root of 3. And across from the 90-degree angle, it would be 2K. If we use this relationship, we can solve for the sides of a special right triangle. There is a unique relationship between the sides of a 45, 45, 90 triangle as well, and that says that across from the two 45 triangles, we'll call both of those K. And then across from the 90 angle is K times the square root of 2. These relationships all come from using the Pythagorean Theorem. So if we remember the Pythagorean Theorem, it is a squared plus b squared equals c squared. I know you guys are all chanting that along with me. That's where all of these numbers and values come from. So you can always use the Pythagorean Theorem to find the sides of right triangles. We're just going to check it out using these relationships to see if they might make things a little bit faster. A little bit of a warning, I'm going to be using decimals for my answers, and since that's what you're going to be looking at with a lot of your vectors, so go ahead and grab a calculator or open up a calculator in a new screen or something so you can work these along with me. Here we have a 30, 60, 90 triangle. I know that because the 30 and the 90 are labeled, and properties of triangles says the other one has to be 60 because they have to add to 180. Now if we remember what those relationships were from the other slide, across from the 30 was where we said that was K, and across from the 60, which would be this one that's not labeled, we said that was K times the square root of 3, and across from the 90 was 2K. So now that I have this written down, I can see that K equals 2, and 2K equals U, and K times the square root of 3 equals V. So if my goal is to find the other two legs of the triangle, to try and find U and V, I just need to plug in for K. I know that K equals 2. So if we go to this second one, we know that U equals 2 times 2. So U equals 4. And V equals 2 times the square root of 3. And if we are using our calculator, we are going to get 3.46. We'll round to the hundredths. So now we know all the sides of our triangle. We know that the sides of our triangle are 2, 4, and 3.46. And that was just using special right triangles. Let's label this one like we did the other. First, think, what kind of special right triangle is this? What relationship am I going to be looking for? This is another 30, 60, 90 triangle. If we remember, across from the 30 degree, the one that's not marked, this was K. Across from the 60 degree, that was K times the square root of 3. And across from the 90 degree, that was 2K. Sorry, I made a mess. All right, so we can go ahead and use sort of solving equations in order to find K and find all three sides. So we know that 8 times the square root of 5 equals 2K. Because we know this, we can solve for K. I'm going to divide both sides by 2. Which means that K is 8 times the square root of 5 over 2, or we could say 4 times the square root of 5. If we're going to use a decimal, we can do that, although our answer is going to get rounded all weird. If we use a decimal, the decimal for this would be 8.94. Alright, so that actually helps me out a little bit, because if we look over at our triangle again, we have y is k. So the side y is 8.94. The side x is 8.94 times the square root of 3. And if we're going to use decimals, we might as well go all the way and multiply that by square root of 3. And we end up with x being approximately 15.49. So we can write down our three answers, our three legs. We knew that one leg was 8 times the square root of 5. That was given to us. We know that one leg is 8.94, and we know that one leg is 15.49. First, identify your triangle. It is a 45, 45, 90 triangle. And we know that across from the 45-degree angles, these would both be K. And we know that across from the 90-degree angle is K times the square root of 2. Now we need to solve for K so that we can find all three sides of our triangle. In this case, I'm going to look at the 7 and the K times the square root of 2. So K times the square root of 2 equals 7. Divide both sides by the square root of 2 and we will know what K is. So again, we're going to use our calculator and get the decimal answer for that. Looks like our answer is 4.95 approximately. So that lets us find all three sides actually, because m is the same as k and so is n. So I can write my three sides as 4.95, 4.95, and 7. Identify the triangle. 30, 60, 90. So let's go ahead and write in our K statements. Across from the 60, we know that that is K times the square root of 3. Across from the 30, we know that that is K. And across from the 90, we know that that is 2K. Ooh, I like this one already. We know that 8 and K are the same thing, so we know that K equals 8. I've got one side done. That means that V, one of the other two sides, is 8 times the square root of 3. So if we want to use our calculator to find out what that is with a decimal, that would be about 13.83. I like to round up there. And U is 2K, so that would be 2 times 8, which is 16. Now we have all three sides of our right triangle. Our three sides are 8, which was given, 16, and 13.86. Alright, one last right triangle to consider, and this is A, 45, 45, 90. So if we remember our K rules, across from the 45s, these are both K. And across from the 90 is K times the square root of 2. Alright, so we need to solve for K first. It looks like the 4, the hypotenuse, is going to help me do that. So K times the square root of 2 equals 4. Divide both sides by the square root of 2 and we'll find K. So using our calculator to get the decimal answer for that, we get 4 divided by the square root of 2, which is 2.83. You guys probably had that done before me. And the other two sides are K, so we already have 2 of our sides. Our third side was 4, so we're already set to go. The three sides of our right triangle are 2.83, 2.83, and 4. It's just using the formula, just remembering that. I'm going to post some tips for how you can remember those relationships. You can always use the Pythagorean Theorem, but this is just a shortcut. I know you're thinking, why would I want to find the sides of a right triangle? Well, right triangles are involved with vectors. Vectors are used for calculating distances and displacements when you're looking at movement, something that is very important in almost every little thing you do each and every day.